Good morning all, I am Joyeta Moietree and yes, I am back with our episode 2 of Fun to Explore series. And of course, very predictable, in the last episode I discussed about the first chapter from thermal physics, simple kinetic theory of matter. We explored mostly about compressibility and those were from session 1 and session 2. So it's very predictable that today I'll be talking about session 3, which is heat capacity. So in Fun to Explore, we usually explore something new and fun. So before exploring something new and fun, let's just review a little what we have learned. So we basically learned mostly to calculate heat using the formula Q equals to mc del theta. And we also learned about the term C, that C stands for specific heat capacity. And not only that, we also learned the formula of electrical energy and we learned how to involve the formula of electrical energy and this one to solve math. So the formula of electrical energy, for your information, is W equals to PT. It was a very short chapter, that's all we learned. So from this very short, pretty boring chapter, what is even there for fun to explore? Well, you might think there is nothing, but personally, this episode is my most favorite from all the 5 episodes. So, as you see, there is a new term which is C, specific heat capacity. In session 3, all of us learned how to explore, how to find out the mathematical definition of specific heat capacity. So we know the mathematical definition of specific heat capacity, that is, amount of heat needed to change the temperature of mass 1 kg by 1 Kelvin or 1 degree Celsius. But today we want to look at specific heat capacity from the viewpoint of physics. We want to explore the specific heat capacity from physics point of view. So what is even specific heat capacity? Well, our basic knowledge, specific heat capacity is a thermal property that all substances have. Some can have more, some can have less. That is basically very simple. But my question is, basically our Fun to Explore zone in today's episode is, what special achievement does a substance achieve by having specific heat capacity? Anyone? Any idea? Well, of course, all of you know, but since I didn't know till the last moment, so I am a new learner of this, so let's explore it together, only for me, please. Alright, so specific heat capacity is basically the ability to hold heat, which means objects that have high specific heat capacity or substances that have high specific heat capacity will absorb or release more amount of energy than the others. My goodness, you know, if I knew that there is so much this, then the other sort of discrimination in thermal physics, I swear I would never love it. You can actually make it like a literature thing, that in literature we do this, we make a contrast, that at the beginning what the character felt and at the ending what the character felt. We compare the feelings. So you can like compare it, that in session 1, Joyeta felt that she said it is her favorite special session, she loves thermal physics. And now at the end, she's finally saying that she doesn't like thermal physics, she realized that there is a lot of discrimination in thermal physics, so she kind of hates it now. And you know, you're right, I hate it. And because I hate it, I won't speak about it. Bye. Okay. Since you guys called, that's why I came. I wouldn't come, okay? Because you called, that's why I came. Because I care about you all. Alright, so yes, specific heat capacity. We know that basically objects having high specific heat. Why is it so sound? I don't understand. Alright, so objects having high specific heat capacity, they will basically absorb or release more amount of energy to change their temperature. So let's take an example because it's still confusing. Let's take water, a very common liquid with some uncommon exceptions, and please note that among the common substances we have, water, it has the highest specific heat capacity. So specific heat capacity of water. So specific heat capacity of water is 4200 joules per kg per Kelvin. Now what does it mean? It means 1 kg of water needs 4200 joules of energy to change its temperature, or basically to raise its temperature by only 1 degree Celsius. Or 1 kg of water needs 4200 joules of energy to decrease its temperature by only 1 degree Celsius. That's big. And in fact, this shows that because water has high specific heat capacity and it is absorbing or releasing more amount of energy to raise its temperature or decrease its temperature by small degree Celsius, it actually takes longer time to get hot or to get cold. And that is why, in fact, water is used as a cooling agent. So since we have learned a lot of things, let's just differentiate between high specific heat capacity and low specific heat capacity. What is the even difference between them? So let's explore. Are you guys enjoying with me, or am I the only person who is enjoying all this? You're getting bored. Possible, because I have weird choices. Alright, so this is the comparison. You see high specific heat capacity and low specific heat capacity. So objects that have high specific heat capacity, they will have a slower rise in temperature. Whereas low specific heat capacity, they will have a faster rise in temperature. Then high specific heat capacity, more time to get heated. Low, less time taken to get heated. High does not lose heat easily because it is the ability to hold heat. Low loses heat easily. High, it is heat insulator. Low, it is good conductor. This point is something I will actually explore after we study conductivity and all these things in another episode of Fun to Explore. Yeah. Alright, so and then high, more ability to hold heat. Yes, as I have said. And low, less ability to hold heat. These are basically the differences, and please don't memorize these differences. We understand the thing. If we look at it and read it a couple of times, it will act as a common sense. You don't have to memorize it and all these things. I hate memorization. Please don't. And one last thing is, before solving any math, because when it comes to O-levels, this sort of like relating to the from physics point of view, specific heat capacity, it mostly deals with it in paper 1, which is MCQ. So in MCQ, sometimes it happens that it can confuse you. Suppose they ask that why does it absorb more amount of energy? If the thing is, suppose if the question asks why does it absorb more, then of course it has high specific heat capacity. Now if the question asks which one will have a faster increase in temperature, then of course because it is low specific heat capacity, because it takes less time to get heated. So you need to understand these key terms. You need to look at and read the key terms very carefully. That did they ask more time to get heated, faster, or absorb more? You have to understand the situation that is given. If you understand it, very fine. And sometimes what happens is like a gadha like me, I know all the things, I understand all the things very well. In the examination, my goodness, I make stupid type of mistakes. And that's why actually, in fact, that's why my parents call me gadha. They don't call me gadha for no reason. There is 100% reason. That is, I read the things, I know the things, and still I make mistakes. That is like the stupidest, I don't know, idiotist thing. Alright, so let's end. Before ending, one small example I'll talk about. That is, 3 years back, I went to St. Martin. Probably one of the most beautiful places I have ever seen. Did you all go? Anyone? Alright, let me know in the comment section if anyone of you have went to St. Martin before. So in St. Martin, I discovered that when I walk, the sand, it feels much more hotter or warmer than the seawater. Why is it? Of course, because sands, they have much less specific heat capacity than water. That is why, with the same amount of heat, sand will be much more heated than the water, because less heat is needed to heat sand up, to warm up sand. And that is it. We are basically done with today's Fun to Explore, and I hope it was real fun, because I was excited to do this episode with you all. And in the next episode, we will be exploring something more fun, something more cool about thermal physics. Until then, stay home, stay safe, stay tuned with Explore with Joyeta, because I gave a new writing about internet and virtual world. I hope you have already read it. And most importantly, stay cool with life, and thank you.